All right, and we're back. We left off in 13.1. We talked about factoring out the GCF, or greatest common factor. So this is our second type of factoring, which is called factor by grouping. So before we get into the main type of problem, let's look at an example like so. All right, so if I try to factor this the way we did the last lesson, finding the GCF, what do both of these have in common? They both have the fact that they're being multiplied by x minus 4. So x minus 4 is actually the GCF. So if I pull out the GCF, open my parentheses, and then remember we're thinking about the distributive property, x plus 4 times what would give us this combination? Well, that would need to be a 2, because 2 times x plus 4 is our first combination, if you will. Sign is a minus, and then x plus 4 times what would give us this combination? Well, that would need to be x. So now I have factored that. So what we're going to do is take that one additional step. So here's an example. So if you are trying to factor this, is there a GCF? Do they all have a common factor? And the answer is no, they don't. So this is where we're going to learn this new method. So the first step is to separate into two pairs or groups. So that's where the grouping comes from. Now, for our purposes, almost always we're going to be able to just group the first two and the second two. So now what we're going to do is factor each pair. Let's say factor out the GCF from each pair. So each pair will have a different GCF, but that's okay. So in other words, we're going to do this like two different problems. So for these two, and I just kind of make this squiggly mark to remind myself that this is my pair. So they both have x's, but how many do we need? Remember, you always take the smallest, so x squared. And then if I want to figure out what this would be, x squared times what is x cubed? Well, that would be x to the first, plus x squared times 3 would give us the 3x squared. We're going to bring down the middle sign. Whether it's a plus or a minus. You don't want to lose that. Bring down the plus, and then we're going to factor this pair. So the GCF here is 5, and if I pull that out, that leaves x plus 3. Okay, so now we're going to factor out the GCF. So what is in parentheses should match at this point. For this section, if they don't match, it means you made a mistake. So again, looking at this combination and this combination, what do they have in common? What is the GCF? And that would be x plus 3. So if I pull that out, what's left is x squared plus 5. So it's always going to be whatever's in parentheses written once, because that's the GCF, times the other values here connected by that sign. All right, so next example. Okay, so again, we have 4 terms. The directions will say factor. So we're going to separate them into 2 pairs that do have a common factor. Now we're going to factor the GCF from each pair. So here, the GCF is y. And if we factor that out, that leaves y plus 1. Bring down the sign. And then here I can factor out an x, and that leaves y plus 1. But we're not done yet because it's still addition. When you're factoring something, you must end with multiplication. So looking at this term and this term, the GCF is y plus 1. Factor that out, pull that out, and that leaves y plus x. So that's going to be our answer. All right. Let's find an example with a different sign. All right. Here we go. So we have this pair and this pair. Factor each pair. So here I can factor out an x squared. Remember, you take the smallest exponent, and x squared times x squared plus 1 would give us that one. Bring down the sign, which is a minus. And then what these have in common, the GCF, is 4. Now here's where you have to be careful. When you think about the distributive property, you're multiplying by a -4 now. So -4 times what would give us a -4x? Well, that's still going to be an x. But a -4 times what would give us a -4? So we know 4 times 1 is 4, but the sign here has to be a plus. So you don't automatically bring this sign down. A negative times a positive is a negative. But again, we have a little built-in check for this section at least, because again, if these don't match, you'll know you did something wrong and to go look for your mistake. To finish up now, GCF is x plus 1, and that leaves x squared minus 4. All right, so let's see what else we need to know. Hold on one sec. All right, the next example, a squared plus a. Let's make that a 2a squared. 2a squared plus a plus 2a plus 1. All right, so separate into pairs. Now here, the GCF for these two is a, and that would leave 2a, because a times a is a squared, and a times what is a? That needs to be a plus 1. Bring this sign down. Now here's where you might see a little problem, because what will go into 2a and 1? The greatest common factor is just 1. But we need to show that, because the way our steps are written, we have to express both as multiplication. So now we can see from this term and this term that the GCF is 2a plus 1. So we factor that out, and then what's left is a plus 1. So even if they don't have a common factor greater than 1, you still need to express that as multiplication in order to do this next step. So hopefully this will help you finish up section 13.1, factoring by GCF and grouping, and I'll see you next time.